Yeah, g'day guys. Now if you've watched my last couple of movies, you'd know that I've got the vertical head off my milling machine at the moment because I'm just working on fixing the vertical spindle. I'm waiting for some material for that, like lint-free cloth and stuff like that. So while I'm waiting, I figured I'd do a job I've been meaning to do where I can kind of showcase my vertical slotting head. Right, so what are we working on this week? Well, this is my Inca thicknesser planer, made in Switzerland back in the 1980s. It's a lovely little machine. I've done a couple of videos on it already, so leave a link up the top. As with all planers, it uses drive rollers to drag the wood through, but unfortunately, the original design which Inca used never worked that well. It was a round belt drive to a worm gear to a chain, and it was very maintenance intensive and not very reliable. A while ago, I dumped that system and replaced it with a stepper motor, which turned out to be underpowered, and also my mount system sucks. The way this mounted was with 3 big screws on to pick up existing features on this frame, but because I tried to use the original chain, which is kind of short, I ended up with my motor mount covering the top mounting screw hole here. So yeah, I made it kind of unassemblable, and I also didn't give enough space for the chain, so the chain was dragging on the motor mount, and I made the mount far too thin so the thing bent. Basically, a terrible design. So to fix all of these issues, I'm going to need more torque, a longer chain, and a more robust motor mount. Let's get into it. Mill time. So why get another stepper if I've already got one installed? This is one of those Nema 23 Planetary reduction gearboxes. It's got 20:1 reduction gearing, but it requires the motor to have an 8mm output shaft, whereas the stepper I already had was, I think, 1/4 inch. After you insert the motor, you put an Allen key in through the side to tighten up the clamps, and then you can plug them over. It's also nice of them to supply it with the key, and having a threaded hole in it, it's easy to extract. So this thing looks pretty nice. In fact, it looks very nice. That stepper motor, it shafts too long. The Planetary gearbox only accepts a very short shaft, so first thing I need to do is just lop off a 1/4 inch off the end of it. Because this room has my Schaublin in it, I'm kind of loath to use an angle grinder in here. The instructions for looking after motors probably includes the instruction, don't clamp it in a vise. But I promise I'll just do it lightly. First off, let's just see if it is mild steel, because if it is, let's just see if I can zip through it like that. It really is. Let me just get a pliers so it doesn't start spinning on me. New pliers and a new hacksaw. Treat yourself for Christmas. I'll leave a link below. Right, just quickly clean this up with the file. That's better. I had to buy a new chain wheel. The other one I used was, I think, 10 or 11 teeth. There's no way I'd be able to get a decent size hole in the hub on the 10 or 11 tooth one. So I've taken what I guess is probably the smallest one, which I can bore out and still get a key into. This is designed for a key. That's actually a very good point. Did I think that through, that this needs a key? It's got a 14mm output. I've got a 24mm outer diameter, so that should still work fine even with a keyway cut into it. It's currently got a hole in it already. I'm guessing it's probably 6mm or something like that. So I need to take it out to 14mm. I mean, it's only a chain drive. I'm not going to bother dialing it in on a 4-jaw chuck. I really don't think it's going to be that important. At this point, I'm going to be using this tool, which is a carbide drill, and I think it's 12mm if I remember rightly. You know, there's not much point writing code to drill a single hole like this. I don't really need to pick drill it. It's already been pre-drilled, so it should be fine. Just have to remember to turn the lathe backwards with this tool. Oh, I just realised. No rings around machines, huh? Makes lovely little, lovely swarf. Yeah, that's a carbide tool, this one, carbide shank, not just the inserts. It's quite nice to use. So this should now be 15.5. Come on. Oh yep, that feels nice. Right, next up I need to shape that keyway. Some time ago I made this tool for the shaping head, but unfortunately it's not going to fit. Now the key is 5mm or slightly under size, so I'm going to need to grind a tool out of high-speed steel to cut that keyway. I find on a bigger high-speed steel tool like this, it's often best just to get in first with the angle grinder and rough the part out, then to go straight to the tool and cutter grinder. Right, with that now roughed out, we can start moving over to the tool and cutter grinder. And while we're getting that set up, we can get a groove going. Wee bit of clearance angle. Oops, that's way too much. So if that's neutral, probably 1/2 degree is probably about fine, as long as it gives me some clearance. And we'll also rotate it for a little bit of side clearance. Next up, we'll flip the steel over, and now we also reverse that back clearance angle. Okay, that wheel's become so loaded up it's barely cutting. Time to dress it. I'm aiming for 5mm wide. Right, now this tool is going to plunge vertically, so I'm going to want just a wee bit of back relief back off the cutting edge there. At the front, I'll have to give that a little bit of back rake. But for the back relief, I'm going to be a little bit more generous, I guess. Maybe 5 degrees or so. Oh wait, now I need to swing across this way. So that's not going to work. Let's flip that whole vise around. Move it back a bit. Just a quick lick on the whetstone, and this tool will be ready to cut. Right, well that should be just about good enough to cut a keyway. Right, to mount that in the slotting head, I've got just an aluminium spacer to sit behind it. Just pack it up a little. This is designed for 16 by 16 tooling, and this is 10 by 10, but luckily I've got a couple of bits of 3 by 3, so that gets it nicely centered while I crank it down. Those can then come out. Oops, I think that's a wee bit too fast. Let's slow that down. I really should get around to putting the holes in the base to bolt this down. You know, I never really know how to center the cutters with these things. I mean, if I just go off side to side, 4.6 on that side, 4.5 on that side, so looks like I just need to go this way, about 5/100ths. Terrible timing for the battery to go flat. So at about 15.6 or so. Oh, I don't need much more. Just offer that up. Okay, that's going to fit nicely. It's a little bit tight across the edges, but nice press fit. Cool, I'll call that done. Yeah, it sure makes a nice clean keyway. Pretty happy with that. Okay, that fits nicely. I'll probably end up having to cut the end of this shaft off. I think it's probably too long. Now normally I drill a hole through the top here and put in a grub screw which presses on the key to lock the whole thing. But unfortunately, that wall thickness is really not enough through there. So what I'll do, I'll put the grub screw on the opposite side where I've got a thicker wall, which means I'll just have to file a flat onto the shaft at the same time. Right, with the pulley mounted I can now offer it up and see how it'll fit. I don't think there's any way this would still work with the existing chain because, yeah, there's no clearance to get past that mounting feature. And the second reason to need a longer chain is to get some clearance between this motor and this whole switching unit. I'll bring the motor down here a bit further, once again pick up those existing 3 holes to mount off. Right, well let me go and jump on CAD and conjure up a new motor mount. By the way guys, did you see that FreeCAD is now at version 1? Big effort from all the developers to get it to this stage, and it's working really well. Thanks very much guys. So I extruded the basic shape, then put some standoffs on it, put in a space for the motor mount with some slotted adjustment sort of features, and then sent it off to the X1 Carbon to print it out. I used unnecessarily fine settings on this, so it was probably about 6 hours printing time. Now I also wanted some covers for the electrics on the Nema 23 motor, so I got them off the Thingiverse. Thanks a lot to HM Electronics for designing those. They look really nice. And printed in a bit over an hour. Oh, whoops, I forgot to turn on the setting for support material, which is why I got all this horrible looking gunge across here. But to be fair, the printer's done a pretty good job of bridging that space. While this looks kind of horrible, it picks up and fixes it. This is only a rough prototype. I'm probably going to have to improve the design anyway, so it doesn't really bother me too much. Just have to remember on the further versions of this to actually set support material. Okay, so even spanning that large distance, that large gap, it quite quickly picked up and made solid material again. Okay, so I just bolted that block up just to make sure it will actually work, and it's looking pretty good. Seems reasonably rigid. If I find that it is still too flexible, I guess I'll have to end up picking up this feature and supporting the motor from up here as well. Mail time. Ah, good, my new chain arrived in time. I was a bit worried because it's already Saturday night and I'm hoping to put this video up tomorrow, so a bit concerned if it didn't arrive on time, but here we have it. I don't think this one had a split link in it, I think it was a continuous chain. Well, you really see the difference between a good printer of 10 years ago and a modern BambuLabs printer. So if you haven't upgraded your printer yet, get one for Christmas. I'll leave an affiliate link down below. We can even save a few percent, and it would help the channel. I'd appreciate that. The melt-in threaded inserts are also really cool technology. Right, with those wires now connected up, let's see if it actually works. I think I set the speed on the driver extremely low because I was direct driving, so I'll probably have to go in and re-jumper that for a different number of steps per RPM, but it's good to know it works. I got these slots too big on this prototype one. I expect to reprint this. I also forgot to put radiuses on a couple of the corners, so I'll modify that in the final version too. The idea of these slots would be that they would capture the nuts and prevent rotation so that I can just tighten them up from the outside. The nuts are 8mm across flats, and I think I made a radius diameter error here and made those slots 16mm across flats. So. I also made these holes exactly 8mm, so of course I then have to try and crank the screws in. On the model I've already increased those to 8.1, so they should just slide in. I sure hope we've got enough wrap on this one once it's finished. Okay, so like that it's still a bit loose. I do still have a bit more adjustment to move the motor down, but I'll have to take this block off to do the adjustment. Right, that's a bit tighter. I do still need a bit more adjustment at the bottom though. But anyway, that's that plugged in. That must be this way. Obviously I'm going to need to put a cover over this, but let's cut a piece of wood, see how it goes. Got a nice thick bit of cherry here. Okay, well that was a very light cut, but it did drag it through without any issues. Main problem is it's far too slow, so I just need to go into the control cabinet and change the jumper ring to increase the speed of the stepper motor. So how is this currently jumpered? I've got 1 on, 2 off, 3 on, 4 off. On, off, on is 2 amps, but this is now a 4 amp motor, so I can actually go to on, off, off. Not like I really need it, but... I then played around with the jumpering of the steps per revolution. No, that's still too slow. Jumper it up 1. That's maximum speed there. That's still kind of slow. The highest speed is off, on. Right, well that drive's now working well. It's not a limiting issue. The drive rollers slip on the board before this stalls, so that's good. I will make those minor modifications to the motor mount block and reprint it, but it seems to be doing its job quite nicely. I do need to go and investigate what I used as a step generator. Maybe it's got a jumper setting on it where I can increase the maximum number of steps, because the whole thing's running pretty slow at the moment. Ideally, I guess a drive speed double what I've got would be perfect. But hey, thanks a lot for watching. I'll catch you next time.